talking about inverse trig functions. And I said yesterday that I like when we use arc sine, arc cosine, because it reminds us that the A represents the angle. And so we're really trying to find the angle, and this is not a good example, but here, up here. We want to find the angle whose cosine ratio is 1. And if you can keep that in your mind, the angle whose cosine ratio is equal to -1, it kind of helps you remember, oh, I want to find the angle measure. Okay, and so you can refer back to your unit circle. So I really like the A for angle, much better than the sine inverse notation that is only there because it needs to fit on our calculators. That's the only reason. So let's finish up. Here we are, examples 7 and 8. So in these examples, these are actually pre-cal examples. So I don't know if you did these in pre-cal trig, but I do. We spend a lot of time on this. And so just to maybe refresh, and if you don't remember, that's great. That's what this is for. We're going to be able to sketch a right triangle and evaluate the ratios without a calculator. And so here we have x equals the arc cosine of 2 over radical 5. Okay, so once again, this is saying some angle, angle x, has a cosine ratio of 2 over radical 5. And we can draw that triangle. And because it's cosine, I know that when I draw that triangle, it has to be, arc cosine has to come from the top half of the unit circle. So I'm only looking at that top 2 quadrants of the unit circle between 0 and pi. And I'm going to draw a triangle. Well, these numbers, 2 and radical 5, are both positive. So I'm going to draw them in quadrant 1. And if you remember, cosine is which ratio? SOHCAHTOA. Yeah, there it is, adjacent over hypotenuse. Have you seen it written this way? SOHCAHTOA. Have you seen it written that way? It's pretty good though, eh? Yeah. So this is adjacent over hypotenuse. And so I'm going to draw it because the adjacent side is +2. We're going to draw it over here. So I'm going to draw a triangle, a right triangle coming from the origin. And, and this is some angle x. So there's my little angle x, is the ratio adjacent over hypotenuse. So the hypotenuse gets the radical 5. And so then I have 2 legs here. Which leg gets the 2? The bottom. Along the x-axis, we would have the adjacent over here would be the opposite side. Can we figure out the third side of this triangle? Yeah. Absolutely. Pythagorean theorem. And so to figure out here this, I'm going to call it y. We have 2 squared plus y squared equals radical 5 squared. So we get 4 plus y squared equals radical 5 quantity squared is just 5. Okay. Subtract the 4, so we get y squared equals 1. And take a square root, we get y equals plus or minus 1. But we're in quadrant 1, so what must y be? 1, positive 1. Positive 1 because we're going here in quadrant 1, that's a up, so we get y equals 1. So we have 3 sides to the triangle. So once you complete your right triangle, can we figure out the tangent ratio according to angle x? Yeah. Absolutely. Tangent is opposite over adjacent. So opposite over adjacent would be 1 over 2. And so really, if you have a very good understanding of inverse functions, you can always create a triangle, complete the triangle, and solve from there. Let's try another here. So we have y equals an angle whose sine ratio is x. Well, that's not just an x. it's an x over 1, because when we deal with sine, cosine, and tangent, having fractions is really nice because they're ratios. All right, so once again, I'm going to draw a triangle. Again, this is arc sine, and when we're doing sine inverse, they have to come from the right side of that unit circle. So it's either I'm going to draw it in quadrant 1 or draw it in quadrant 4, or maybe both. Let's see here. So this says some angle whose sine ratio is x over 1. Well, maybe that opposite side is positive. So maybe I'm going to draw that here in quadrant 1. So I have my angle y, has a sine ratio of, again, this is opposite over hypotenuse. So the opposite side is x. The hypotenuse is 1. And can we figure out the third side? Absolutely. I don't know. I'm going to call it A. All right. And so let's see. A squared plus x squared equals 1. I need to solve for A. So A squared equals 1 minus x squared. And then I can take a square root. So A is either plus or minus the square root of 1 minus x squared. Oh, interesting. So this is the square root of 1 minus x squared. Can that A be plus or minus? This is interesting. Let me draw another triangle, because maybe that value for x is negative. So maybe I can draw a triangle down here. So y is, again, an angle whose ratio is x over 1. That's interesting. So to find the third side here, even if x is negative, I'm going to do the same exact thing to solve for A, but we square the x, don't we? All right, so that really doesn't come into play, so it's always going to be positive. This is still going to be 1 minus x squared for that third side of the triangle, no matter how you draw that triangle, which is kind of interesting. And so I can, since I have my completed triangle, find the cosine according to the angle y we drew. And cosine is adjacent over hypotenuse, so adjacent over hypotenuse. And even if I did it here, adjacent over hypotenuse, it doesn't matter. It would just take care of itself. 1 minus x squared over, oh, just kidding, adjacent over hypotenuse. 1, that's what I meant to say. Adjacent over hypotenuse. Oh my God, I'm losing my mind. Adjacent over hypotenuse. Okay, so cosine of my angle is just the square root of 1 minus x squared. That's supposed to be a 1. There we go. So either way you do it, we get the same for the cosine, which is kind of interesting. All right, questions on those? Did you do that in pre-calc?
Variation, but like not this, like
not this
intense. There were more numbers.
Yeah.
Less radical.
Yeah. All right, so there you go. So how do we lead into? These are pre-cal. So how do we work? From example 8, so using this information, we want to find the derivative of the angle whose sine is x, or x over 1. All right, so I'm just going to go ahead and say, hey, we're going to let y equal the arc sine of x over 1, or this x, which is exactly what we did there. And let's see, I'm going to do some fancy math here, and I'm going to go ahead and say, hey, I want to take a sine of both sides, sine ratio of both sides, because sine of an arc sine, since we're here in lovely quadrant 1, those are just going to cancel out. And so I get sine of y equals x. And then I can go ahead and take a derivative. Derivative according to x. So d dx of both sides. What is the derivative of sine y in terms of x? Derivative of sine? Cosine y dy dx equals the derivative of x in terms of x? 1. We can get dy dx by itself by doing what? Divide, so we get 1 over the cosine of y. Well, wait, we just found that. That's the cosine of y. And so that is 1 over the square root of 1 minus x squared, because we already found that. Kind of interesting, right? Okay, so the derivative of arc sine is 1 over the square root of the thing squared. Okay, and you can see that right here, the derivatives of inverse trig functions. So there it is, the derivative in terms of x of arc sine is 1 over the square root of 1 minus x squared. How does the derivative of arc cosine change? Negative. That makes sense. Everything with a c's got a negative, right? And then tangent, no radical in there, it's a positive. Which again, we could figure out by just setting up a triangle and solving for the tangent according to y if we wanted to. And you would see that, oh, you're just adding the two together. So that's very cool. Now, of course, if x is something more impressive, say, than just an x, you do have to remember to take a derivative of the inside, and so that's what the u prime is for. So don't forget the chain rule if you need it, okay? And again, some of these will have negatives because the derivative of 1 minus something squared, you drop your power and it now have a negative 2 in front, okay? So keep in mind that there's like a chain rule that could exist here, and that's what that is, the derivative of the inner piece there. All right, so be a little bit careful. Let's practice a little bit here. So g of y, we want to differentiate the tangent function. So this is like, imagine this is just a x, or I'm just going to call it a u. Doesn't matter what I call it. And so g prime of y, the derivative, an arc function is going to be 1 over. Tangent is just 1 plus the thing squared. So 1 plus u squared. So 1 plus the thing, which is 2y minus 1 squared. But we've got to multiply by the derivative of the thing, the derivative of u. So what's the derivative of 2y minus 1? Times 2, yeah. All right, so we get 2 over 1 plus 2y minus 1 quantity squared. All right. Number 11 here, again, it's not just a plain old x, it's a fancy thing. So once again, you can think of it like a u, something other than we have to be very careful of. It's x to the 1/2. All right, so we want to find f prime of x. This is arc sine. It's got the 1 over with the square root, and we're subtracting. So this is 1 over the square root of 1 minus u squared, 1 minus u being squared, times the derivative of u. What's the derivative of x to the 1/2? 1/2 x to the negative 1/2, yeah? Good on that? Yeah? Okay. So just a little bit of cleanup there. Let's see. If I wanted to clean that up, the best way I think would be the 2 is in the denominator. X to the negative 1/2 is square root of x in the denominator. And then we have square root of 1 minus, what is the square root of x squared? Just x. So that's interesting. Questions on those? Okay. All right, again, arc cosine here. We have a u function, so something more complex than just a plain old x. So we've got to do the chain rule. H prime of t, cosine, got a negative. And big square root 1 minus u, so the natural log of t squared, times the derivative of u. What is the derivative of the natural log function? U prime over u. Natural log of x, the derivative, is just 1 over x. And so this would be, 1 over t. So 1 over t in this case. So again, a little bit of cleanup. I have a negative 1 in the numerator and a t in the denominator, the square root of 1 minus, and I would just leave it written like this, natural log of t quantity squared. Make sure that your radical extends far enough. That is very important, that you have a little tail on your radical that says, stop here, okay? Be very, very clear what is inside and outside of a radical, and also be very, very clear what's being squared. Because if you were to write the square root of 1 minus the natural log of t squared, that is not right. That does not convey the same thing. That's t being squared, not the natural log of t, the whole thing being squared, okay? So that would be a no-no, and you would lose points, which of course you don't want to do, because how easy is that to fix, right? You know, so make sure you're conveying the math you mean. Okay, questions on that? All right. I like it when there's just formulas, because they're just, easy. All right.